Hello everybody. So in these videos I'll be walking through the review problems that I had picked up for you for your exam tomorrow. And before I get started, I just wanted to point out that I will be putting these into two videos. The first video I'll see how many problems I go through the first half, so about 50 minutes, and then I'll put the second video and I'll start from there. Anyhow, go ahead and get started. Problem 1. So we want to do, this is an optimization problem. So we have two equations. And so the first equation is just xy equals 40,000. That's just from the area. Then we want to maximize the perimeter. So then we have, I'll just call it f of x comma y equals 2x plus 2y. Plus 2y. Finally, we just want to be able to get this in terms of one variable, so we have to do that by a substitution. I'll go ahead and solve for y. So y equals 40,000 over x. So we can go back to our equation, get this in terms of one variable by substituting the y of 40,000 over x in for y, so we get 80,000 over x. Next, take the derivative, set it equal to 0. That's how you get your relative extrema. So we have 2 minus 80,000 over x squared. Set it equal to 0. X is going to give you 200. It'll give you technically a plus or minus once you take the square root. However, we know that you don't want negative length, not in our domain either. So we keep the 200, and then x is going to be 200. Y will be also 200. And then you want to go ahead and check to make sure it's a minimum. You should know how to do that. If not, you can go through previous lectures. But anyhow, I would have them check, and this will be, the dimensions will be indeed 200 feet by 200 feet. So 200 feet. We're done. Box that answer. Good. Alright, that is number 1. Moving on to number 2. This is yet another optimization problem. And the distance resistance, so off to the side, I guess I'll go ahead and kind of draw what you're doing. That's really crooked. So this is technically like a parabola on its side that is shifted over 9 units and kind of reflected. A few transformations applied. But basically we just want to try to minimize the distance from the origin to any point on this curve. So I know I need the distance equation. So I went d equals just the square root, and since it's origin, that's 0, 0, so it's kind of like our x0, x, and then 1, y0, so distance is just x squared plus y squared. And I'm going to go ahead and do distance squared. The reason is because I can still minimize it, but without having to use chain rule again. So we're going to go and do that. Now, I want to get this in terms of one variable. I'll go ahead and get this in terms of x, because I usually like to do that. So if you solve for y squared, you get 9 minus x over 4 is going to equal y squared. Go ahead and substitute that in. So we have our d squared, which I can now call it f of x, because it's just in terms of x only. X squared plus 9 minus x over 4. Next step, take the derivative, set it equal to 0. So we do f prime of x equals 2x minus 1/4. Solve it. Now, set it equal to 0. Right, take the derivative, set it equal to 0. Now, we just want to solve for our x, which is going to just be 1 over 8. Positive 1 over 8. And that is the x value. Now, we want points, correct? So we have to actually take this x value and kind of plug it up there. That's a really curvy line. Anyhow, so we have 9 minus x over 4 equals, that made a weird thing. Okay. Over 4 equals y squared. I meant to put in the 1/8. My bad. Alright. So we put in the 1/8. So then we get y equals, it's going to be the square root of 71 over 32, I believe. And it'll be a plus minus because we took the square root of both sides. So then for your final answer, you'll have 2 points, and 1 point will be the 1/8, and then one will have a positive and one will have a negative y value. Then we have 1/8. Good. Put a box around that. That will be your final answer then. Oh, that did not. Oops. Here we go. Try boxing it again. There we go. All right. Moving on to number 3. So this is when we have, this is yet another one optimization problem. I guarantee you will have one of these on the test. So I just gave you 3 to give you a sample. The past two are definitely a little bit harder, but anyhow, keep going. For our start with what we want to optimize, the equation we want to optimize is it's going to be in terms of L1 and L2. We want to optimize the length of the wires, so that's just going to be L1 plus L2, right? Total length is just add them together. Now to get L1 and 2, we want to get this in terms of x, and we can see that there's in the bottom, oh, those are both x's. But how do we get those in terms of x? Well, just use the Pythagorean theorem of a squared plus b squared equals c squared. When you do that, you will get L1 equals the square root of 100 plus x squared, and you'll get that L2 equals the square root of 100, and then plus 30 minus x squared. So, and then when you add all that up, you're going to get 100 plus 900 minus 60x plus x squared equals the square root of 1000 minus 60x plus x squared. And that's all for that. Good. So now that we have that, we can get our nice equation into just our f of x, kind of just one variable. So we have f of x equals just square root. This is just mere substitution again. Third. Good. All right. Next, we want to take the derivative and set it equal to 0. So take the derivative. This is both of these are chain rule. So you chain rule for the first term, chain rule for the second term. What's going to happen? That's just going to go x for the square root 100 plus x squared. Same thing here. So this will end up being x minus 30. That's derivative inside. Over this x 1000 minus 60 x plus x squared. Good. Set this whole thing equal to 0. And then you just basically solve for x. I'm just going to do some algebra and get the x out of this. So we have, go ahead, subtract 100 plus x squared on both sides. So we get this. X squared. There we go. All right. Now we want to cross multiply the two. So we have negative x square root plus x squared equals this quantity x minus 30, the square root 100 plus x squared. Next, what I'm going to do, I'm going to square both sides just because having radicals, it's pretty hard to solve for x. Yeah, as you can see. So square both sides, we get x squared times 1000 minus 60x plus x squared, and that's going to equal this x minus 30 squared. I'm going to go ahead and FOIL that out. So that's 60x plus 900 times 100 plus x squared. So what's going to happen next then? We just do this, go ahead and kind of distribute everything in. 60x to the third plus x to the fourth. That's going to equal our, just do the x to the fourth. I'm going to distribute x squared first, I guess. Minus 60x to the third plus 900x squared plus 100x squared minus 6,000. That's equal to 6,000x plus 90,000. 90,000, good. Okay. So, nicely, a lot of things are going to cancel. So, x to the fourth cancels, so those cancel. Then this 1,000 is actually going to cancel over here. That's also 1,000. So we're just left with 0 equals negative 6,000x plus 90,000. Alrighty. So solved for x, you're going to get x equals 15. Now to check if this is a minimum maximum, if you actually do your number line, you'll find that this is actually a minimum. So we're going to have to compare that with the endpoints. So endpoints were 0 and x equals 30, and that's just from the diagram of the pole. They go all the way to the left pole or all the way to the right pole. That's 0 and 30. So next you just do kind of take the, put this into your original function that had all your x's, but not the derivative, just the original function. Do f of 15, f of 0, f of 30, f of 30, and you'll get this one is approximately 36, I believe, and then the other two are approximately 42. So you'll find that, okay, indeed, f of 15 was the minimum, and to get the maxima, the maximums, it's just these when it's at either pole. So for your final answer, you can put at either pole. there, pull. There we go. Perfect. Alrighty. Then, go back to here. I'll just show you. That is all the way here and also here. Going on to number 4, this is just finding antiderivatives. Pretty straightforward. So we do capital F of x. And this is just kind of like reverse power rule, right, for all of these. 1/4 x to the 4th plus 14 over 3 x to the 3rd plus 3x. And don't forget your constant of integration. If you forget that, it'll just be like a minus 1 or 2 points probably. That is this one. Alrighty. Next one. Same thing. I'll go ahead and call that capital Y. Is going to be just x to the 3 over 2. That's just by adding 1 to the exponent. And then we want to multiply by 2 over 3, so it actually be 2. And then minus antiderivative, sine x. Oh, and I almost forgot. Yeah, don't forget that constant of integration. Yeah, you can lose easy points that way, so do not forget that. Alright. Box that. Oh no, it didn't box. It's gonna box. There we go. Alrighty. Now for part C. Part C. Okay, same thing. We get 1/2 x squared minus 2 cosine x. And minus because that's just the antiderivative sign. Then we want to do, now we have to put the plus c. The thing is, we actually don't leave this as plus c. We have to use, we're given an initial value, so we have to use that. So we have just do f of 0, which is -6, and then that first term goes to 0. The second one goes to just cosine of 0 plus c. So that cosine of 0 is really just 1. Then you have, add 2 to both sides. You get c equals -4. Then for your final answer, you will have just f of x, oops, whoopsies, there we go. Okay, final answer, f of x equals 1/2 x squared minus, oops, can't write today, 2 cosine of x plus, or not plus, minus 4, there we go, minus 4, alrighty. And there we go. And I'm going to go ahead and stop here. In the next video, I will go over the next 4 problems. See you there.